All right. Good evening to all the grade 12 students. Welcome back to the last minute preparation for your board examinations. Yes, as I said, we are going to do last 30 days intense preparation for your board examination. Ma'am, what is intense? You very well know. We are going to learn each and every concept of your NCRT, all the 10 chapters which are there for your board examinations. I'm going to drill it up. Yes, so let's start a journey. To all the students who are there with me since long, thank you so much. For all the new students who are joining, welcome to the channel, and I promise you'll be scoring 98 plus. I'm not going to give any fake promises, students. Vani ma'am is true to her services. Let's start. So as I said, follow the series. I'll be sending the videos on regular basis. But what are we going to cover in this series? Yes, as I said, you have 10 chapters, right, for the board examinations. Yes, so these 10 chapters, I'm going to teach you multiple choice questions, very short answers, short answer questions, assertion and reasoning type, content based analysis, analog type questions, and some important previous year's questions. So follow the series, students. As I said, very important, we are going to focus on 4 important things. First, my work or this one is I'll be trying to upload, or daily uploads would be there, daily uploads. So I'll be uploading the videos. If one day, if by chance any emergency, if it is missed out, I'll be uploading it the very next day. So daily uploads would be there. Please follow it. I'll be uploading the video around 5:30 in the evening. So please note it. Second important thing, I request you to buy a 300 pages long register today. And 300 pages long register, you're going to watch the video and note the question and answer and study it. Yes, go to the shop and buy it today. Okay, next important thing, before the examination, every day early in the morning, get up at early in the morning, and exactly at 5 o'clock revise. Early in the morning at 5 a.m. please revise whatever is given to you on the same day. Okay, revise it early morning 5 a.m. just revise it every day, so that's easy. And no, most important thing is believe yourself, students. Believe yourself. Vani ma'am is there with you all, and you have to believe yourself. Stay calm. So what is our logo now? Our logo is work hard in silence. Work hard in silence. So we need to work hard in silence, then we can prove the society that yes, we are there. So let's start our journey. Let us not waste time. Let's start. Before everything, as I said, multiple choice questions. Let us understand. I'll be giving you small tricks for this. Let's read the question. Which one of the following pairs will form ideal solution? If this question is given, there are 4 examples given to you. They have given me which is the ideal solution concept. So when ideal solution concept is given to me, only one option you should remember, or one concept. What is it concept? The concept I'll be putting in star. For an ideal solution, or whichever example, the ideal solutions will have similar structure. Okay, they will have similar structure, first important thing. And the ideal solutions will have similar polarity. This is what you should remember for your board examinations. Similar structure and similar polarity. Let us see, chloroform and acetone, both the structures are different. Correct. Okay, this is ruled out. Ethanol and acetone, both the structures are different. Ruled out. N-hexane and heptane, yes, both the structures are similar. That means it is an ideal solution. Next, phenol and aniline, both the structures are different. So I have to remember for ideal solutions, similar structure and similar property, or similar polarity is important. So take that. This question is over. So nice, isn't it? Let's go to the next question. Careful, note it carefully. Next important thing. Increasing the temperature of an aqueous solution will cause what? When you increase the temperature in an aqueous solution, what will happen? That is what they're asking. Okay. So concept is increase of the temperature. This is okay. Now what is it in aqueous solution? Okay. That means something is dissolved. So what should I remember? Just go. What options are given? One is molarity and one is molality. Only these 2 formulas I have to write. Do I have place in the next page? No, I don't have place. So I'll work out here. So first of all, let us start with molarity. All right. Yes, check. Molarity formula is what? M is equal to N by V. Perfect. Okay. That means M is inversely related to 1 by volume, as the question says. All right. M is inversely proportional to 1 by volume. According to Charles' law, what is volume related to? Volume is directly related to temperature. According to which law? According to Charles' law, right? Now you only tell me. Now both simple. Just see. Now what are you doing? You're increasing the temperature. What will happen? Volume increases. Done. Automatically, when volume is increasing, temperature is increasing, as you see, molarity, what will happen to the molarity? Molarity will decrease. All are related according to this formula. Simple. So once again, molarity is inversely related, volume is directly related. So when both are increasing, automatically your molarity will decrease. Now you only go back to the question, increasing the temperature, what will happen to the option? Molarity is increasing or decreasing? Molarity is decreasing. So this option is wrong. Molality, it is not related to your temperature. It is not related because you are basically talking about weight of the solvent, correct? So this is also ruled out. So what will happen here? Molarity is decreasing. So concept is the students, easy, simple question, simple answer, direct, no waste of time. Over. Then next comes, which of the following conditions is correct for an ideal solution? Again they're asking ideal solutions. As I said earlier, ideal solutions, if you see the example, you have to remember same polarity, same structure. If you see the parameters, what is this, students? For ideal solutions, all are equal to 0. Delta H mixing, delta H volume mixing or enthalpy mixing, everything is equal to 0. Yes, for non-ideal and non-ideal solutions, the parameters will change. So for ideal solution, conditions are this. Perfect, easy question. Let us see the next question. For the determination of molar masses, okay, for the determination of molar masses of which one of the polymers and proteins, means high molecular weight compounds, which colligative property we're using? So they've given me 4 colligative properties. Let us take all 4 and see. First of all, RLVP, okay, relative lowering of vapor pressure. What is the formula? P naught A minus P by P naught A is equal to, it is nothing but WB into MA by WA into MB, correct? No, this is your relative lowering of vapor pressure formula. Now you tell me, is there anything that we are talking about the molar mass of the polymer? See, normally here it depends upon the number of moles of the solute, or it depends upon the number of solute particles, correct? Now, yes, so here there's no concept of the major or the high molecular weight compound. So RLVP is ruled out, okay. Next important thing, delta, elevation in boiling point. Delta TB is equal to KB into M. Perfect? Yes. Now here, as you see, it is again dependent upon your molarity. It's not talking about your highly molecular weight compounds. Third one is osmotic pressure. Pi is equal to CRT. Yes. So pi is equal to CRT. Here the concentration, it's talking about the highly molecular weight compounds where they have high polymer weight biomolecules. We are going to use osmotic pressure. So depression freezing point also, let us write this. This is Kf into M. Correct, no, students? So you only give me clarity that osmotic pressure is used to calculate high molecular weight compounds, and we are going to use the concept of colligative property here. So osmotic pressure is the right one. Okay, let us go into the next concept. Next, pure water boils at 373.15 Kelvin and nitric acid boils at 359 Kelvin. So in the isotopic mixture of water and nitric acid, both are boiling at 393.55 Kelvin. Distilling the isotopic mixture will cause. Okay, what is this concept? Let us first write the basic details which we understood. Before we mark it. What did they say? They said pure water, first of all, pure water is combining with nitric acid. Okay, nitric acid, and both are forming an azeotropic mixture. This is what is your azeotropic mixture. Okay, right. So what did they say in this? Pure water boils at 373 Kelvin, they said. Okay, this is boiling at 373 Kelvin separately. This is boiling at 373.15 Kelvin separately. Nitric acid is boiling at 359.15 Kelvin separately. And the azeotropic mixture is boiling at 393.55 Kelvin separately. Okay, so I have to distill it to separate the azeotropic mixture. So now what is the concept? in this what percent of pure water and what percent of nitric acid, we don't know, but we have to remember from the azeotropic mixture. We very well know the azeotropic mixture whatever is formed, this azeotropic mixture is going to have 68% nitric acid HNO3, and it is also going to have your 32% water particles. This is what is the concept. Okay, so when you see which concentration is less, water concentration or water percentage is less. Water percentage is less. This is understood till now? Easy? Easy. Now, what you should remember is, how should I solve this question? What should you understand? Remember always temperature dependency. Okay, temperature dependency is inversely related to 1 by azeotropic mixture of solvent. 1 by azeotropic mixture in solvent, rather azeotropic mixed in solvent. And what is this? I didn't understand. What is this azeotropic mixed in solvent? Nothing, students. You're mixing two which have different boiling points, correct? So when you see initially your 393.55, so what did I write initially? The mixture wise, when they are boiling, 393.55 was the temperature, which is more than the initial temperature of 373 Kelvin and 359 Kelvin. Yes or no? This is individual temperatures and this is mixture temperature. Now you tell me, both will boil at 393 Kelvin, and for me it is difficult for me to separate. It is very difficult to separate the particular mixture. Now, so distillation of azeotropic mixture, what will happen? Because both have the composition in liquid and vapor phase. So normally what do we say? Distillation of azeotropic mixture will distill over the same composition according to the definition. But in the liquid and vapor phase, they have different temperatures, correct? So what should we remember? For me, when they are boiling at a higher temperature, for me it is difficult to separate. So this is the concept. Let me go back to the question and see. Now you see pure water 373 and nitric acid 359, and azeotropic mixture of water and nitric acid boils at 393. Distilling the mixture will cause. So your mixture, what will happen, they're asking. Now pure nitric acid will distill? No, because they're together, it's not possible for me to separate. Pure water will distill out. This is also wrong. One of them will distill over the small amount. This is also wrong because they are boiling at higher temperature. For me, it is difficult to separate. So you will take the correct option. Both of them will distill over in the same composition as that of the mixture being distilled. Simple. Because both are boiling at a higher temperature than individual, for me it is difficult to separate the mixture. Easy concept? Easy. Let's go a little bit further. If it is difficult, let me know in the comment section. I'll try to make it more simpler. Let us read this question. If 5% by mass of glucose, okay, 5% by mass of glucose, molar mass is 80 gram per mole, is isotonic with 1% by mass of a substance X. What is a molar mass? Okay, simple. First of all, let us write, students, 5% by mass. Okay, they said 5% by mass solution. Of which one is this 5% by mass of solution of glucose? Okay, of glucose is what they said. Okay, so what is 5% by mass? 5% by mass means it is 5 grams. As you said, yes, it is 5 grams. 5 grams of solute, whichever solute they have given. So it is 5 grams of solute. So they said 5% of mass of this one is isotonic with 1% solution by mass of a substance X. There is one more percentage substance which is of X. So for isotonic solutions, what should you remember? Isotonic solutions, what should you remember? You have to remember pi 1 is equal to pi 2, because isotonic means they'll have same osmotic pressure. Yes, so same thing, concentration of the C1 is equal to C2. Is this clear, students? Iso? Okay. So according to the formula, pi is equal to CRT, right? So now let us go to the next page and see. So concentration, how much was it, students? How much is given? Weight by molecular weight. Okay, right. Let us write. Weight, how much did they give me? 5 grams. How much is a molecular weight? 180. How much is a this one? How much did they give me? 5%. Okay, 5 by 0.1. 5% is no. So 0.1 is equal to 1 by 1 gram. 1%. See, they give given here 1%. So it is 1 gram divided by m2 into 0.01. Both are isotonic in nature. So pull out m2 here. How much are you getting? 180 divided by 5. 5 ones are 5, 3s are 15, 36. So m2 is equal to 36 gram per mole. Gram per easy, easy. That's it. Easy question. So come back to the option and mark as 36 gram per mole is the answer. Is it okay, students? Let's go to the next question. Easy question. Gradually we'll go. So let us read. When 2.5 grams of a non-volatile solute was dissolved in 50 ml of water, it gave a boiling point elevation of 0.52. Okay, 2.5 grams of non-volatile solute, it was dissolved in 50 ml water and it gave a boiling point elevation of 0.52. The molar mass of the solute Kb for water is 0.52 kg. Let us write what is given. So first of all, for me, given data, what we know, given data is what? Delta Tb is nothing but 0.52 degrees centigrade. What is Kb? Kb for water is 0.52 km minus 1. Correct? Alright. According, what is the formula which we are going to use? The formula which we are going to use for delta Tb is delta Tb is equal to Kb into m. What did they ask me? They asked me the molar they basically asked me to find out the molarity. Okay, so let us come back and write the formula. What is this, students? This is molality. Okay, let us further expand it. Okay, there's no space here. I think I'm not left a place. I'll solve it here only. So first of all, 0.52 kb is equal to 0.52 into moles of solute, correct? Moles of solute divided by weight of 1 kg of solvent. 1 kg of solvent. Correct, na, students? Yes, this is the thing. So can I erase this little bit so that I can, where is my eraser? Okay, let us take an eraser and see. Sorry. Okay, do I have an eraser here? Eraser, so that I can get space here. Okay, let me erase this and see. You have already written the data, right? So that the formula and sum is clear for me to do. Okay, done. So I have written that formula. Now let us take the pen. Okay, this is done. Now let's further solve it. First of all, you know, when I cancel this and this, I'll be getting 1. Okay, 1 is equal to same moles of solute by weight of 1 kg of solvent. 1 kg of solvent. That's correct, right? 1 kg of solvent. Okay. So now let us understand for moles. What is moles? Moles is nothing but weight by molecular weight. Correct, na? Number of moles is equal to weight by molecular weight. Now you will understand density is equal to mass by volume. Cross multiply this. Density into volume is equal to mass. Now what is density of water, students? Density of water is 1 gram per ml. Correct, na? 1 gram per ml. You accept? Now you divide this into this 1 gram per ml into 50 ml, because volume is 50 ml of water. 50 ml, that is what they have given, 50 ml of water. So ml and ml gets cancelled, so I get 50 grams here. Okay, 50 grams. Till now, is it clear? First, what did I do? I wrote the data, then I took the delta TB formula, then I've gone to the density this one formula, then gradually I calculated the density of water. Now I'll use my eraser and again do the remaining sum. Okay, let me erase the whole thing for you. Okay, I'm erasing. I think it's clear till now. If anything, any doubt, please join the Telegram. I'll be giving you the explanation, the Telegram also, if anybody has doubt. That's not a problem. So what did we get? We have got now your density of water. Correct. Now how much did I get? Density of water 50. So let us go back to the formula. So the same formula I'm going. Delta TB is equal to Kb into M. Now what did I get? Delta TB, I have cancelled there. I have got 1. how much is the students, your value given, weight. The weight is 2.5 grams, so 2.5 grams divided by molarity into 50 by 100. So 1 is equal to 2.5 into 50 by 1000, rather 1000 comes up, divided by your cancel it here. I can think, okay, here once I can cancel it here. This comes to 51s, this is 52s, correct? So 2.5 into 10, okay, this comes to, this is molarity, right? Molarity, okay. Now further proceeding, 1 into 2.5, 1000 by 50, this goes 20 times nm. So take out molarity now. Molarity is 2.5 by 10 into 20, correct? Then automatically I get m is equal to 50 gram per mole. Is it okay, students? Let us see the option. 50 gram per mole is the answer. Alright, so if any doubt, please let me know further. Let us go to the next question. Next question. Yes. To increase the solubility of carbon dioxide gas in soft drinks, the bottle is sealed under. So carbon dioxide gas, which law is this? Henry's law, correct? So whenever they ask you carbon dioxide in soft drinks, remember one option. Option question number 1. If you have to increase carbon dioxide to increase carbon dioxide solubility, first of all, what should you do? The bottle has to be sealed. Bottles to be sealed under pressure. Bottles to be sealed under pressure. Okay. Option 2. Solubility is directly related to your pressure of gas. It is related to pressure of gas. Am I right, students? Am I right? Yes. These two concepts. Now go back to the question. To increase the solubility of carbon dioxide, it should be done under low pressure. Wrong. It should be done under high pressure, high temperature. Wrong. It should be done under constant pressure. Wrong. It should be done under high pressure. So the clues are here. The concept is there. Easy. Let's see. Next question. A solution of a pair of volatile liquids A and B show negative deviation from Raoult's law. This is because of what? So whenever they ask you negative deviation, because you have to remember positive and negative, remember students, always for positive deviation, rule number 1, and for negative deviation, rule number 1, same thing. First of all, always remember, for positive deviation, A, B interactions are less than A and B. Okay, positive. That's why they break the bond and evaporate. In negative deviation, AB is greater than AA and BB. That's easy. Now let's see. Same concept is further to remember. In positive deviation, your P naught or PA rather, PA is greater than P naught A XA. PB is greater than P naught B XB. Vice versa. PA is less than P naught A XA. PB is less than P naught B XB. So if you remember this, I think this works. Let's see. So what did they ask me? Negative deviation. In negative deviation, P naught A is greater. This is the wrong option. The intermolecular forces of AABB, this is less. They said less. This is also wrong. This is for positive. This is for positive. This is for positive. Delta H mixing and delta V mixing. This option also is important for you to understand. In positive deviation, delta H mixing is greater than 0. Delta V mixing is greater than 0. Okay. In this case, delta H mixing is less than 0. Delta V mixing is less than 0. So if it is less than 0, you only tell me, students, less than 0. Okay, both are positive means if it is less than 0, is it positive? You only tell me. Yes, it's going to the negative value. Okay, it's less than 0. Let us see which one is correct. Near option. Intermolecular forces of all of the above is wrong. Okay, okay. How can I judge this? A, B. Okay, so here you see A and B are less than this one, means indirectly it is this only, na? A and B are, A and B is greater than AA and BB. Okay, so they've misled us. They wanted us to get confused with this. So we have to be careful with the question. This option is, okay, this option, let us erase it. Sorry, let us erase this. Okay, let me take this, students. Okay, this is wrong, this is right, this is wrong for this is wrong for this. The correct option is option B. Okay, this is done, students. Is it okay? Done. Let's see. So remember these points whenever you are studying your positive and negative deviation part. Study these parameters and go, so that's easy for you to. Chalo, next question. The number of moles of NaCl in NaCl in 3 liters of 3 molar solution. Okay, number of moles of NaCl. Already the option is marked. How should I work it? NaCl in 3 liters of 3 molar. Okay, what is molar? Molarity is nothing but N by V. Okay, how much is molarity? 3. What is the volume? 3. This 3 liters volume, molarity is 3. Apply it. 3 is equal to N by 3. N is equal to, cross multiply, 3 into 3, 9. 9 moles. So the answer is, so remember molarity formula application and directly doing the sum. Easy? Easy. Now, low concentration of oxygen in the blood and tissues of people living at high altitude is due to. So people living at high altitude. First of all, high altitude means what, students? What is high altitude? What happens at high, when you go? Okay, sorry, close it. Okay, what happens at high altitude? Tell me, what happens at high altitude? At high altitude, the partial pressure, whatever partial pressure is there, the partial pressure will be less than the pressure at the ground level. The ground level pressure, correct na? Ground level pressure. This is the concept. The pressure will be very less. That's why they wear oxygen cylinders and go. Okay, so because of this, you have low concentrations of oxygen. Where the oxygen is there? In the blood as well as tissues. Both the oxygen is less in the blood as well as tissue. Correct. So because of the low concentration of blood, the climbers whoever are there, what will happen to the climbers? Because of this low oxygen, they feel weak. They also means think, they can't think clearly. Correct na? This is the complete concept. And what is this called? This is called anoxia. Now you only tell me, low concentration of oxygen in the blood and tissues at high altitude is due to what, students? Is due to low atmospheric pressure. Perfect. So that's the answer. Easy. Concept is here, only application. Next question. Considering the formation of breaking and a strength of hydrogen bond, predict which of the following mixtures will show positive deviation. So what did I say? Yes, remember one clue, students. Simple. Whenever they have a positive deviation concept, yes, I have to check for hydrogen bonding. Check for hydrogen bonding question. So if you check for hydrogen bonding, which one? I'll tell you how to remember. So methanol and acetone. Okay, first one only. So methanol, let us write. Methanol formula, is there a hydrogen bonding? Oxygen, this is a hydrogen. Then dot, oxygen. We have double bonded compound in which you have CH3 and your CH3. Okay, is this not a hydrogen bonding? Yes, it is a hydrogen bonding between methanol and oxygen. This is your hydrogen bonding. Now, tell me, students, pure methanol, first of all, this pure methanol, let us understand. Pure methanol has which one? It has hydrogen bonding. Okay, accepted. Then acetone, when you introduce acetone to that, so what will happen when you introduce acetone to that? It starts breaking the hydrogen bond. correct? It starts when you introduce acetone, breaks hydrogen bonding. It breaks hydrogen. When hydrogen bonding is broken, what will happen, students? Attractions weaken. The attraction between that attractions weaken. When attractions weaken, what will happen? Bonds break. When bonds break, what will happen? They will show positive deviation. When bonds break, they will show positive deviation. Correct? Now easy. So you should check for hydrogen bonding in which one it is there that this concept works. So methanol and acetone. Chloroform, any positive hydrogen bonding? No. Nitric acid and water, HNO3? No. Phenol aniline? No. So methanol and acetone is the right answer for your option which shows. So hydrogen bonding is the concept for your positive deviation. Next question. Which of the following statements is false? They've already marked this. This option is right itself. Let us, how can we rule out how can we do this? We'll see. So, different solutions of sucrose of same molality prepared in different solvents will have the same depression freezing point. Okay. So, what did they do? They have taken, let us see how I can justify it. First of all, solute, both the cases the solute is what? Both the cases the solute is sucrose. Sucrose and sucrose. Okay. Correct? They have same molality. Molality is same. Okay, let us say 0.1 molality and here also 0.1 molality, both. But they have different solutions of same molality, but solvent is different. This is solvent 1 in this case, here solvent 2 in this case. Both are different. Till now, they're asking me, will they have the same delta TB? Delta TB, will it be same for both? The questioning us. Let us understand the concept. Now, how should I justify this? Okay, this is clear, students. Let me erase this and take it. Okay, I'm using the eraser part. Okay, I'm using the eraser part and come back. Pen. Now, delta TB, delta TF is equal to KF into molality. Correct? Na? Done. In this case, delta TF, let me expand, KF into W2 by M2, number of moles into weight W1, which is nothing but weight of solvent. Done. They said depression of freezing point of solution of same molarity and different solvent will be same. What did they say? They said in this case, in the first case, delta TF has in that which has same molality, okay, but they have different solvents. This is what they said, same molality and different solvents they said. Okay, both will have same TF, delta TF. This is what they're trying to justify. Now you see the relationship, students. Delta TF is inversely related to your solvent. Wait, you only tell me if the solvent is different, delta TF will be different because both are inversely related. That means the concept is two different solutions of sucrose, same molality, different solvents, means freezing point also will be different. Perfect. So the correct answer, yes, both will be, they see here the delta TF is different for different solvents, Now what did they give me in the question? They have given me in the question, it will, you have to prove it false. This is the false statement which we are taking. They said it will be same. This is wrong. It will be different. Easy. So this is the question gradually. Now let's go to the next question, students. Okay, the value of Henry constant of KH is what? So basically, let us write the formula. P is equal to KH into X. Correct? Now what is KH? KH is inversely proportional to 1 by X. Okay. What is P? P is equal to partial pressure of gas. What is X? X is equal to solubility of gas in liquid. Okay. What is KH? KH is Henry's constant. Okay. KH is Henry's constant. Correct. Now you only tell me for highly soluble gas, was highly soluble, which is that, let us write that. For highly soluble gas, KH is very less. Correct. Okay. For low soluble gas, KH is very high. Correct. That is what is a concept now according to this formula. Now you read the value of constant KH is, greater for gases for higher solubility, greater for gases. Okay, for higher solubility, we see this, when it is highly soluble, KH is less. This is wrong. Greater for gases with low solubility. Yes, solubility is low means KH is high according to this formula. This is right option. This is wrong, this is wrong. That means your KH and your solubility of gas are inversely related. KH and solubility of gas are inversely related. Easy? Easy. Next question, students. Okay, this place is empty. So what is the conclusion? KH is inversely related to solubility of gas. That means if your KH is greater, solubility will be lesser. If KH is lesser, solubility will be high. Easy? Next question. Consider the figure and mark the option. So remember this question. It's easy. Let us understand this question. So what did they give me? They said water will move from, this is SPM students, not 8, don't get confused. Water will move from A side to B if the pressure lower than the atmospheric pressure is applied. Okay. Water will move from B to A if the pressure greater than osmotic pressure is applied. Water will move from side B to side A if pressure equal to osmotic pressure is applied. Water will move from side A to side B if the pressure equal to osmotic pressure is applied in the piston. Now, simple students, as we know, this is reverse osmotic concept, correct? So, remember, if the pressure greater than the osmotic pressure is applied on solution side, what will happen, students? When it will apply in the solution side, what will happen? Yes, automatically the particular solution, okay, whatever this solution is there, no, it will start moving from the B side to the A side. Okay, because the reverse osmosis is happening. You're applying pressure more than the osmotic pressure, means the whatever solution is there here, the particular solvent part. So water, the pure solvent part. So water will start moving, the reverse osmosis concept. So water, whatever is there from here, this part will start moving because you're applying more pressure. It will move from B side to A side because osmotic pressure is applied on piston B. This is going on. You're applying more pressure. So the correct option is B, and the concept here is reverse osmosis. Okay, students, that's done. So I'll be again sending you one more video today only. So careful, note the remaining questions. We'll be doing short answers at the end of the video. I have more number of questions, so please stay connected. Quickly note it. One more video will reach you at 8:30 a.m. Stay connected. Thank you so much.